All right, so next thing we need to do is deal with scientific notation. That really should be review for you guys, but the new part is to deal with the sig figs and understand how they apply to scientific notation. So you should already know that scientific notation is a way to represent very large or very small numbers as a small number multiplied by a power of 10. Right, these two numbers here, 2.010 times 10 to the fourth and 3.20 times 10 to the negative third, are both in scientific notation. Right, so some of the things that we need to focus on is understanding that exponent. If it's positive, that meant it was a very big number. If it was negative, it was a small number originally. But I'm just going to take these two numbers out of scientific notation and show you how those sig figs come into play here. So first off, right, that 2.010 times 10 to the fourth, right, looking at it right now, you should be able to see that it has 4 sig figs because that 0 final to the right of the decimal does count as being significant, and then the other 0 is trapped. So it does have 4 sig figs. So when I'm taking this out of scientific notation, I have to be careful. I need to show my precision. So that positive 4 means that I'm going to take that decimal and move it 1, 2, 3, 4 places to the right. And so I'm going to end up with this number, 20,100. But you should recognize right now that my expanded form, that 20,100, as is, only has 3 sig figs. Whereas my original number in scientific notation had 4 sig figs. So if you see that, you need to recognize that, and you need to make sure that you don't lose precision in the long run. If I want you to take a number out of scientific notation and it had 4 sig figs to begin with, it better have 4 sig figs when you're all said and done. So this is one of those cases where we have to put that line over that 0 that we want to be significant, because there's no other way to show that that's significant. So again, scientific notation isn't new. Taking that number out of scientific notation should be something you could already do, but understanding that sig figs still apply, and recognizing that this 0 before and after is different as far as our rules are concerned. You need to make sure that you don't lose precision when you're working with scientific notation. The next example, 3.20 times 10 to the negative third. If I want to take that out of scientific notation, all I have to do is move the decimal 1, 2, 3 places to the left this time, because it should have been a small number with that negative exponent. And I will get this value here, 0.0032, 0.00320. And the only thing here is that I need to make sure that I understand that that 0 was there before. It still needs to be behind the number after. Before and after, in this case, I have 3 sig figs. You're usually not going to lose precision here, but don't drop that 0. If it was significant before, it's still significant after, so it has to stay with the rest of the number when it's all said and done. Okay, and then this last example is just a number that's not in scientific notation. You should also be able to put numbers into scientific notation if they're not already. Right, so if I want to put this in scientific notation, I'm going to move the decimal 5 places to the right, which means that my number is going to be 1 times 10 to the negative 5th power. But again, I have to keep precision. My original number had these trailing zeros. My pen's not working. There we go. It had those trailing zeros that were significant. I originally had 3 sig figs, so my number in scientific notation should also have 3 sig figs. So make sure that you keep those zeros all numbers and any given number in scientific notation are always significant. So don't lose precision when you're changing to and from. So that was just a quick review of taking things in and out of scientific notation, but also just trying to point out when you need to pay attention to make sure that you don't lose significance. But I also need to be able to do calculations in scientific notation, so we have another couple rules to add into the rules that we already have. So in scientific notation, one of the things I want you to do is just focus on your numbers, not the exponents, not the powers of 10 originally, and just get answers, right? If I have 2.56 and I'm going to multiply that by 1.5, I'm going to get an answer, 3.84. And I can do that on my calculator because that's fine. That's easy enough to do. And I can even round that appropriately, knowing that I had 3 sig figs in this number and 2 sig figs in that number. So round and get an answer with 2 sig figs, 3.8. But at the end of the day, you do have to deal with those powers of 10, but don't do that on your calculator because that's really easy. Right? All I have to do at the end here is tack on that times 10, and then when I'm multiplying, I need to add my exponents. So a -3 plus a 6 is going to give me a +3. So at the end of the day, my answer is going to be 3.8 times 10 to the third power. I took care of my sig figs. I rounded my answer appropriately. I also dealt with my power of 10. But I'm not going to do all of that in my calculator because I'm going to have to punch in a lot of buttons, and not all of us know how to do that appropriately, so we'll get the right answer. So it's really much easier to just multiply your two numbers and then deal with your exponent when it's all said and done. Make sure you remember sig figs though, and you're counting, so I should only have 2 sig figs in my answer. But at the end of the day, really not that difficult. If I'm going to divide in this next example, again, I want to deal with my numbers first. So I'm going to take 4.20 and I'm going to divide it by 2.3. And I'm going to get a number on my calculator that has way more sig figs than I really need to have in my answer. But if I look at these two numbers, 4.20 has 3 sig figs, 2.3 has 2 sig figs. So when I'm looking at my calculator and I see this 1.826086957, I don't need all of those numbers. I just need 2 sig figs. So I'll just automatically round it. It's 1.8. Right? The 2 doesn't affect it. I needed 2 sig figs. So I rounded down 1.8 times 10 now, and I deal with my exponent separately, remember. If I'm dividing, I'm going to subtract. So I take a 9 minus a -8, remembering that that means I'm actually going to add, and I'll get 1.8 times 10 to the 17th for a final answer here. I don't care if you write down numbers initially and then round them like I was doing on the previous example where I wrote down 3.84 and I drew a line to show where I was rounding. I don't need to see that work necessarily, but I do need you to round to significance. So 1.8 would be appropriate. And then deal with your exponent and make sure you subtract if you're dividing. But multiplying and dividing with scientific notation, pretty easy. Adding and subtracting again is the one that's a little weird that we have to deal with. So this first example is not necessarily in scientific notation, but I could actually write it in scientific notation. Right? I have 6 kilograms, 6.0 kilograms, and I'm adding 3.5 grams to it. You know that you can't just add those things together. You know that with those different units, I can't just get an answer of 9.5 kilograms I can't get an answer of 9.5 grams because neither one's correct. I need to make sure that my units match before I add those two numbers. Now I'm going to rewrite that in scientific notation to just put this into context, right? 6.0 kilograms could be written as 6.0 times 10 to the third power, right? And that 3.5 grams then would be 3.5 times 10 to the 0 power. Now remember, 10 to the 0 power basically is just times 1, so I don't even need to write that at all. But I'm showing that those powers of 10 because that is what the metric system is all about, powers of 10. So adding and subtracting in scientific notation is exactly the same as adding and subtracting using different units in the metric system. So in order to add these things together, I have to make sure that my exponents are the same. I have to make sure that my units match. So I'm going to do that. That's the first step to this. So it doesn't matter if I change my kilograms into grams or grams into kilograms, but they have to match at the end of the day. So what I'm going to do, just because it doesn't really matter which one I do, I'm going to change my 0 over here, exponent, and I'm going to turn it into a 3. I'm going to add 3. Right? One thing that you might want when you're doing this, just off to the side, so that you remember what's going on. Remember, if you move the decimal to the right when you're putting something into scientific notation, you always end up with a negative exponent. And when you're moving the decimal to the left, excuse me, my pen's being goofy, you always end up with a positive exponent. So the same rules apply here. If I'm going to add 3 to my 0 to make those exponents match, adding meant move to the left, so I have to move my decimal 3 places to the left. And then I really have this problem, 6.0, and I'm adding 0.035 to that. And so then I add 6.0035 and I round to precision, and I recognize that my answer at the end of the day is just going to be 6.0 kilograms. Struggle is real today with that pen, but once I round to precision, since that 6.0 only goes to the 10th place, I have to round to the 10th place. That means that adding that 3.5 grams doesn't even really matter at the end of the day. It's still going to be 6.0 kilograms because I always have to use sig figs. But again, right, using the metric system versus adding things with different units versus adding different numbers or subtracting different numbers that are in scientific notation, it's really the same thing at the end of the day. Make sure that your units match, make sure your exponents match, and then you can add and subtract all you want. And you still follow sig fig rules, so you got to line it up and round to precision. But it's really not that hard to do at the end of the day. The next example down here, when I have 2.20 times 10 to the negative 4th, and I'm going to subtract 1.10 times 10 to the negative 5th, I just need to make sure that my exponents match before I do anything else. So I could, in this case, I'd make my negative 4 a negative 5. So if I'm going to do that, I would have to subtract 1. And if I'm going to subtract 1 again, I need to move the decimal to the right this time. And so then I really have a problem that says 22.0, and I'm subtracting 1.10 from that, which can be done fairly easily, right? I'm going to have to borrow a little bit here to make this work, but I'm going to have 0.90 as my answer, and then I round with precision. Since the 22.0 now only goes to the tenths place, I can only have my answer go to the tenths place as well. So instead of 20.90, I'm going to write 20.9. But that's 20.9 times 10 to the negative fifth power. And you'd think maybe I'm done with this, but there is one last little adjustment that I'm going to need to make. Scientific notation only ever has one number in front of the decimal. So if you get an answer when you're multiplying and dividing, adding and subtracting, doesn't matter what, and it's not in that correct form, you have to fix it to make it that way. So I'm going to have to move this decimal to be behind the 2. So I only have one non-zero number in front, and I'm going to have to adjust my exponent appropriately. Since I moved the decimal to the left, I'm going to add 1. Remember that tool that I put top right, because it's useful to have that and remember that. So actually my answer for this one is going to be 2.09 times 10 to the negative fourth. Now one thing I'd like you to see with that, with this example specifically, is that this negative 4 power here, I already had that up here. If you recognize which exponent is smaller and you try and make it match the bigger one, you typically won't have to do extra work at the end. You probably won't have to move your decimal to make your scientific notation look right. If I would have changed this negative 5 over here and made it a negative 4 instead of doing the reverse like I did, I would have saved myself a step. I still would have gotten 2.09 times 10 to the negative fourth. I just wouldn't have had to adjust my answer at the end to get it to be that. It would be that automatically. So if you can think about that and you can do that, that is kind of a shortcut. But if you don't do that correctly, if you change the wrong one, you're still going to be able to get the right answer in the long run. It just, you might not get it as quickly. So these two examples cover all we need to know. You should be able to do the practice on the worksheet. So we're done here.